Are we covering all the routes?
That, Caltrain, maybe the Salesforce Tower.
What's your worldview on why do we now need very strong, powerful voice models?
It goes way back, right? Speech technology is not new. When you have to say hello, it says hello.
Okay, this was my worldview, but after this outcome, this event, it completely changed and now I'm a smarter person. So, how's it going?
Good, man. Very hectic day. Woke up at 7.
7?
Yeah.
Any interesting news upcoming?
So we have this very big customer which is hopefully happy with what you have provided. They had this big list of things they wanted from us and we've delivered on every single one of them so far.
Amazing.
So hoping that goes well. But yeah, apart from that, we are also hiring aggressively. We have a team that is very active. So there's a lot of stuff going on and my context keeps switching between things. But yeah, it's hectic but exciting.
So that is a call for all founding engineers in case you're looking for something smallest. That being said, what are you building for your customers or at least the large enterprises? What are they looking for specifically?
Yeah. So I think the world so far has been modeled, in generative AI at least, has been modeled on a large amount of pre-trained text from internet, right? But if you look at multimodality, like audio, for example, that does not have massive conversational data that we can use to pre-train. That's very high quality, and you can follow the same thing to build a world model for audio. So that's the problem we are solving. How can you build a world model for audio and achieve general intelligence through that?
Wait, so going back to the beginning, can you tell me a little bit about the first voice model that was ever released?
I think there have been various attempts at creating voice models. I mean, voice is not a new technology.
Yeah.
You have a very traditional way to sort of do speech to text, for example.
Yeah. Wait, so I remember that Google icon where you could translate something and press a button and it would speak in some voice format.
Yeah.
What has been the beginning of this and how is it transforming?
Yeah, so it goes way back, right? Speech technology is not new. What was done initially is you literally had these things called phonemes, which is the noises that humans can create. It's let's say, imagine all the possible combination of noises which form a finite set that can generate any form of speech, basically. And so people would literally code those noises into a hardware system, such that when you have to say hello, it says hello.
Oh, I remember.
Right?
Yes.
So then, so we changed from that to a more, let's say, natural way of changing these phonemes so that you could stretch words. So for example, instead of saying hello, you can say hello, you could and this is done to mimic natural conversations.
That makes sense.
Today people have realized the whole approach of even having phonemes is flawed. It's literally an infinite combination of noises that humans can make to generate speech. And so what the generative models are trying to do is model the imperfections of human speech to understand emotions better, basically, and to basically appear more natural when it's having conversations to pass the Turing test. So that's where we are today.
So we started off with something which was quite unnatural and now you're saying we are coming to a state which is very natural. What are the nuances that you want to capture in a natural conversation except words? Do you think there's more to it?
Yeah, there is a lot more to it. So when people think about naturalness, people think it is more about just the audio quality. But it's not just that, it's about context as well. Are you happy when you should be happy? So it's do you have the giggle or the laugh or the pauses that a human would have at the right time? And then obviously, do you make sense, right? And the making sense is not an easy way. Having context is really important. And if you are happy at the wrong time, then it'll not pass the Turing test, right? Because imagine some customer is sad and the voice model is talking to it, and like you're like laughing. Like, yeah, it's very natural, but like it doesn't make sense.
That makes
right?
sense.
So,
Yeah.
so all these parameters coming together is what leads to passing the Turing test, and we are still not there yet where voice models can replace humans, but we are getting very close. We have figured out how to generate natural voices. Now we are figuring out how to do it in multiple languages. Now we are figuring out how to generate those imperfections in voices consistently, and then we are going to figure out contextuality and like making sense for all the last mile use cases.
Do you think imperfection here will lead to more perfection in models?
Yeah,
then?
yeah, exactly.
That makes sense.
Right? Like, basically, this is like modeling the real world where we have not been able to inherently tell like what the structure of the data is, but the models learn like to understand the distribution regardless, right? So today we are entering like the era. I actually compare this with self-driving cars a lot, because even in self-driving cars, which I used to work on before this, you always thought like you are almost there, where FSD, full self-driving, is human-like, but like the last mile problem has been like so challenging that you have a lot of effort that goes into passing the supposed Turing test, which is level 5 self-driving. Very similarly, even in voice models, to pass that level 5 Turing test is gonna take some effort, and there are like a lot of micro challenges what we spoke about that we are trying to solve in that direction.
That makes sense. Are we covering all the routes?
That Caltrain, maybe the Salesforce Tower, who knows,
Amazing.
Maybe the sky.
On that subject, why do you think, what do you think is the, do you think, according to you, what is the sky for the limits for voice, and why hasn't like Siri and Google and all of these companies that have existed for decades now haven't been able to crack this natural voice that you've been talking about?
Sky is basically all humans speak to AI every single day through voice, right? Like, and it also becomes very proactive in the sense that you basically have like a voice call coming from your AI to you, like, hey, like, these, like, to catch up on like very particular topics that are useful to you, like not just like randomly checking on you, but like literally like a friend. Like, you have a personality associated with that AI that plays a certain part in your life, calls you, talk to you, you can talk to it. That's like the Turing test bar to pass, right? I mean, if money could solve the problems, then it would basically lead to like the people with most money solving most of the complicated problems in the world. But building like a world model for audio is a scientifically unsolved problem that is not just dependent on capital, but also completely makes us rethink how models should be built. Today, LLMs, for example, wait for the full context before they start decoding. But that's not how humans like think and speak. You start thinking right when like you hear the first thing, like you start thinking about what to reply, and then you reply when you feel the context has finished, right? That's how audio models should operate. So you will have streaming inputs and streaming outputs, which is very different than how LLMs have been built today. So that's like one example of why it's so difficult for anyone to do it, because you have to fundamentally rethink the way we have thought about intelligence and LLMs.
What's your worldview on why do we now need very strong, powerful voice models for whatever workflows we are integrating them into?
Yeah. So what is happening is now people have seen or imagined what a great AI voice could look like, even though it is not like something that still exists as a technology. But you've seen the movie Her, for example.
Classic example for all AI use cases.
Yeah. So people know what a great AI can be, right? Now we are trying to reach that imagination and the potential that they've shown us. So today what's happening in the market is people are building voice agents which are basically able to do complex tasks like customer support, sales, appointment booking, a lot of tasks which otherwise required humans to just sit on calls and do calls all day, a job which no one wants to do.
That makes sense.
The other part of it is people are also realizing that voice enabled enterprise interfaces are such an easy way to use enterprise products that you completely want to rethink how UX is being built. Now imagine, let's say you have to fill like a HR form. Instead of like clicking on every single button, you just basically say out the things you want to fill in, right? Or like even one step before that, you request the HR form, you say the things you want to fill in, and then you ask it to submit it after verification. That is such an easy way to interact with a complex software compared to you actually having to type things, because typing is a slow process. Now with accuracies increasing in voice AI, you can actually do this in real time. And so a lot of products are just becoming voice first. So those are like the two major trends in the market: voice first products and voice agents.
So that makes me think that and I'd love your take on this, but that makes me think that in the component stack of building AI agents and assistants, voice is now, if not more, but as equally important as the way you interpret like images, any form of modality.
Yeah.
What do you think? What's your worldview on the component stack that an agent should have?
Yeah.
Which will make it the next her for everyone?
Yeah. There are multiple levels to this answer. Let me start with what's out there right now, what works in production at scale. So what works in production at scale for most B2B use cases is something called a pipelined voice stack. So this is basically a speech-to-text model combined with a LLM or an SLM, combined with a text-to-speech model that get orchestrated in real time with like something called a speaker activity detection or a voice activity detection module, which detects when should the agent start speaking. So the speech-to-text translates what the customer is saying into text. The LLM SLM adds the intelligence, and the text-to-speech converts that into hyper-realistic voice. Now the problem with this is when you decode speech into text, you are not able to preserve emotional information. Like the same sentence could be said in various ways. So the next frontier is to build speech-to-speech models. But the important part is they have to be natively multimodal. So they have to take in speech and text and give out speech and text, right? So that is like the next frontier of work that is happening. But it's also important to recognize the flexibility that this pipelined approach gives us, that we lose in the speech to text, like the multimodal model. So in the multimodal model, let's say the agent is not able to hear something because the noise was too high. You will try very hard to debug and figure out like what's going wrong
sense,
where,
yeah.
right? But in this pipeline approach, it's the speech to text that has to be improved on noise. So those are the trade-offs. Now the next frontier is debuggable multimodal models, basically, that can take in speech and text and give out speech and text. Then there are other frontiers in like completely rethinking how these models can like operate in real time and like mimic human conversations, which is basically like the quick interruptions that sometimes you say when you feel someone is talking for too long, to preserve context across very long conversations.
Like right now?
Exactly. Yeah, like how do we even remember where we started with, right? On this last topic of, preserving context, you're working on memory, right? So do you see use cases of memory in voice? I'm sure you have another view to this.
I think in general, memory is important for every part of the stack you end up integrating any form of AI capabilities into. So for example, voice can have reflex actions, and human beings call it like parametric memory. If you touch something hot, you instantly pull back your hand, right? Similarly, voice can have reflex actions. So if someone shouts, "Oh, can you stop talking?" then the reflex action should be the model should stop talking and anticipate for what's coming next. Is it a support request? Is it just like a blank period of quietness? I think those are some of the things that multimodal requires right now, and I want to see how this plays out.
How do you think about the breakdown of what goes in the model and what goes in memory? Because something like a reflex action, you want it like at extreme low latencies, maybe even inherently built in the model, versus something like, let's see what this user liked the last time he came into my cafe, right? Yeah. That sort of goes in the memory, right? So how do you see that memory model sort of differentiation.
I do believe in a world where models, and of course this is already what you guys are achieving, where models become smaller and more efficient, and economically speaking, that's also a much better way to think about it, right? You have smaller models running on the edge, you have like cheaper servers, faster inferencing, but because of that, there will be a very strong decoupling of intelligence with memory. Smaller models will be able to retain, like, it's how human beings work, right? So the forgetting curve, you study for a test, you instantly remember everything the next day onwards, but like after day 7 you remember only 30%, after day 14 you remember 15%. I think there can be a sliding window attention for these models that are smaller. Everything can be in memory of the model if it's happened in like light of recent events, but for longer context, for long-term memory, there has to be a separate management system for these things that's continuously injecting relevant pieces of context into these models, and by virtue of intelligence these models are able to identify, oh, this is the most relevant piece of context to be able to answer a certain question.
Yeah, I think this orchestration of model and memory is like one of the most foundational changes that's happening right now in AI.
Yeah, I think people have now started realizing that all AI technically is stateless, and human beings orchestrate their work and their world in states, right? You have like, of course, you know that, oh, I get on a bus at 9 a.m. because I have to go to work.
Yeah.
Those are not two independent actions. And the same has to be true with any form of intelligent system, where you are giving intelligence by virtue of the system realizing the outcomes from past learnings.
Yeah, that makes sense.
How do you think about long conversation contextual memory?
Yeah. So I think what's important is that the models focus on the important parts of the conversation and do not like misunderstand context, especially over long context. And for that, we are working on this models that are something like a world model for audio and voice, basically. So they have a predictive view of the model. So they're going to predict how the world is going to look like once they speak something, and if the prediction does not match, they're basically going to learn from that and keep improving over time. So that is the biggest unlock in terms of long conversations, and for that it's very important to have great memory, which can basically help the model sort of remember things that the model cannot remember on its own. So we look at the world as a combination of small models with a very predictive view of the world and long-term memory where you can dump infinite context. Does that make sense?
Makes a lot of sense. So for your predictive modeling, can you give me an example with a real-world scenario that everyone could easily understand about, okay, this was my worldview, but after this outcome, this event, it completely changed and now I'm a smarter person?
Yeah. So something as simple as, for example, let's say you're handling a customer. There is a voice model that's handling a customer. It takes in the customer's voice and gives out an answer in voice. Now, it assumed that the customer was actually happy. And so it replied with like a joyous tone saying, hey, I'm happy to help you. How are you doing? But the customer replies in an extremely frustrated manner that my order has been missing for the last 7 days. Where the hell were you, right? And so the model needs to, in real time, understand that it missed understanding this customer's intent.
That makes sense.
And actually start with a more apologetic tone and then continue the conversation as such in a very stateful way, such that it actually remembers the next time it speaks to the customer that was your last issue resolved and were you happy with the resolution? And
have you noticed some other signals that you want to index on, like intention, and something like rejection or something?
Yeah.
Like what are some other signals that you think are very important to index on?
Yeah, I think memory and what is important is currently being not explicitly but implicitly modeled, in my understanding at least, by humans. And so I feel like even with AI, it might be a more implicit modeling of the outputs that the model should condition on. Explicit modeling of whether it is like rejection or whether it's like cues might make the job easy, like in short term at least, but I feel like it will still miss out on like parameters which we will never be able to otherwise model if it was more implicitly modeled through like a latent condition vector that you give to the audio model. So that's my first thoughts at this point of time based on the initial results that we are getting and how human memory works, but we'll see.
That was interesting. What does the rest of your day look like?
I have a call, I have a dinner with one of our investors, then I have some calls late night.
India team
and some customer from Asia as well. Yeah, that's pretty much it. Long day today.
Interesting. Are you excited to get back to work?
I am. Don't ask these questions. Yeah, of course I'm excited. But yeah, it's just today has been like physically tiring. Like it's been a lot of back-to-backs. But we got a lot done today, so I'm satisfied.
Amazing.